So to begin this warm-up, it says, a student graphs the system, y equals minus x plus 3 and y equals minus 2x minus 1. And the student says, but by their graph, which is pictured down below, there's no solution. However, that's incorrect. And your job is to describe and correct the student's error. Well, when I look at this, I notice that if we regraph this equation, y equals the opposite of x plus 3, and put a dot at 3, which they did, and then you move down 1 and over 1. And they did that correctly. However, their line is really short. And so if we extend this line for the entire graph, notice how that's going to change our solution. And if you look at the next equation, y equals minus 2x minus 1, we'll do the same thing. They have it graphed right. They went down 2 over 1. However, when we extend that graph once again across the entire area, things become more clear. Now, because I'm on an iPad, I got a little off. But right there is their point of intersection. That's where they cross. And so if we're describing what the error is, it's the student did not extend their lines. And that changes things because they got no solution. However, the correct answer would be one solution. And our answer would actually be -4, 7. And so notice what graphing can do if you do short little lines or if you do nice long extended lines. And the difference is that that can make in your answers. So as a review, I want to talk about what solutions look like when you have no solution, one solution, or many solutions. And so a few days ago, we did this with graphing. And we knew that when we have no solution, we end up with parallel lines. When we get one solution, we get intersecting lines, and then that point of intersection is our answer. And many solutions is when you're actually graphing the same line, just twice. And so those lines are exact same line because they overlap. However, same lines. What we need to know is what would it look like without graphing? And so let's think about what we know. Parallel lines, we know they have the same slope. So you could analyze your equations and look for ones that have the same slope. Or, just like when we solve just linear equations, we can look at our solutions. So we can look for solutions that don't make any sense. So hypothetically, let's say if you get 0 equals 6, or 2.2 equals 14. They're not true statements. And because they're not true, it means we're not going to have a solution. And that would be, this is what you'll see when you get no solution or something similar. One solution, we know they intersect. And so we should get one value for x and one value for y. And so when you solve, you want to end up with something that equals x equals whatever number you choose. So let's say 7 and y equals 2. You want things that are true in just one situation. Or maybe you find x equals 3 and y equals -1. You're not going to know until you solve, but you want something that will give you one solution, one ordered pair. And finally, with many solutions, we know they have the same line, so that's something you could look for. You could look for the same equations. However, you're not always going to be able to identify that they're the same equations right away. And so sometimes you'll start solving, and then what's going to happen is you're going to get things with infinite solutions, just like we've done also in the past. So you're going to get something that can always be true. So hypothetically, you could get x equals x. You could get 3 equals 3, y equals y, 2 equals 2. Anything like that where it equals itself, where it's always true, is going to give you many solutions or infinite solutions. Now, today we're solving systems by substitution. And off to the side, I have a step-by-step list to help you keep track of what we need to do next. So first, it says to solve one equation for one of the variables. And actually, if we look at our equations, we already have that done for us. We have an equation that says y equals something. So that's very, very helpful. Done. Step 2, substitute this expression into the other equation. So what's going to happen is if y equals 3x plus 4, wherever we see a y, we need to put 3x plus 4. And so if I rewrite it, I'm going to have 3x plus, now instead of y, remember y is 3x plus 4, and it equals 8. And at this stage, you want to check to make sure that you only have one variable. If you get here and you still see x's and y's, we must have substituted incorrectly. So then you want to go back and try again. However, because I only have one variable, I only have x's, I'm off to a great start. And I can solve this because we have to solve for the variable. So I'm going to combine like terms. 3x plus 3x is 6x, plus 4 equals 8. Subtract 4 on both sides to get 6x equals 4. And when you divide by 6, you end up with x equals 2/3 simplified. And so we solved one equation for one variable. So step 2 is done. Next, we're going to substitute this value into that first equation and solve for our other variable. So I have the equation y equals 3x plus 4. Now I'm going to substitute in 2/3 for every time I see an x. So I have y equals 3 times 2/3 plus 4. From here, I can say y equals 2 plus 4, and that gives us y equals 6. Now I have my other variable. Now, last but not least, we need to check the solution to make sure that it's correct. Because remember, solutions are ordered pairs. So I'm saying my solution is 2/3 6. However, before I can be confident in that, I need to check my answers in both equations. So if I get rid of this, nope. I'm going to plug in 6 for my x's and 2/3 for my y's. So I would get 6 equals 3 times 2/3 plus 4. So if I simplify to double check, I get 6 equals 2 plus 4. Yes, that's true. So it works in the first equation. Now we have to check our second equation. And I get 3 times 2/3 plus 6 equals 8. Well, I know 3 times 2/3 is 2. 2 plus 6, it does equal 8. So my second equation also works. So I can confidently say my answer is 2/3 6. Now, with this problem, we have to solve by substitution once again. And our equations are y equals 3x and x plus y equals 8. Now I want you to go through steps 1 through 4 and solve on your own. So pause the video, solve, and then come back and check your answer. Now if you notice, it's color coordinated just like the first slide. I solved one equation for one variable, which conveniently was already done for us. And then everywhere I saw a y, I plugged in 3x into that next equation. So I had x plus 3x equals 8. Notice here, I only have one variable. If I would have 2 at that stage, I know you need to retry your substitution because something went wrong. I was able to solve for x, and then I was on to step 3, where I substituted that into the first equation right here, and I got y is 6. And then finally, step 4, I got my answer is 2, 6, because remember, they're in order to pair, so we have to write it like that. However, we also had to check to make sure it was actually true. Last but not least, we have to solve the system by substitution. Now, notice, if you look at our system, we need to actually do step 1 here. Step 1 is to solve one equation for one variable. We do not have that currently. And so I'm actually going to solve this first equation for a variable. So we currently have 2y equals 4x plus 6. I'm going to solve for y because all I need to do is divide every term by 2. And then I get y equals 2x plus 3. So now I solved one equation for one variable. So notice here we actually had to do step 1. But now we're just back to where we were before. Step 2, substitute this in for every y I see in the other equation. So I'm going to have minus 2x plus 2x plus 3 equals 3. Notice at this stage we want to check to make sure we only have one variable. I only have x's, so I did my substitution correctly. Now I'm going to combine like terms, and I have minus 2x plus 2x. Well, that cancels, and so I end up with 3 equals 3. Now remember what I said before. If 3 equals 3, like we talked about, that's always true. We know it's always true. And so because it's always true, we're going to have many, or you could say infinite, solutions. And so actually, if you go back and look at our two equations, we know that if we get many or infinite solutions, we should actually be dealing with the same equation. And so I'm going to take the second equation and solve it for y, and look what happens. If we have minus 2x plus y equals 3, and we solve for y by adding 2x to both sides, we get y equals 2x plus 3. Notice our two equations now. Now that they've been rearranged, they're actually the exact same equation. And so we know for sure it's going to be many solutions, because if we would graph two lines on top of each other. However, notice, like I also said, just by looking at our equations the first time, we weren't able to see that. And so that's why we need to know that if we get 3 equals 3, or 4 equals 4, or 8 equals 8, we need to know that if it's always going to be true, then it's going to be many or infinite solutions for our final answer.